So the next thing I want to take a look at is how to calculate the length of a curve, something that's not a straight line. And to develop that idea, we're going to start by looking at this demonstration from the Wolfram Alpha demonstration site. And we have a curve that we want to find the length of. And we're starting off here by basically drawing a secant segment between the two endpoints. And we know how to calculate the length of a line, given 2 points. The idea of what we're going to do here is we're going to increase the number of segments. And as you do that, you'll see that the segments start getting closer and closer to the curve. And the idea here is we're going to calculate the length of each segment. Eventually there'll be an infinite number of them. Add them up, and that should therefore, as the number of segments goes to infinity, give us the length of the curve. So if we go back to our curve and talk about finding the length from beginning to end, there's our interval. We're going to break it up into a number of line segments. The more the better, because the more segments we have, the closer the total of the sum of those segments will approach to the curve. So let's just draw a couple for now, and let's just focus in on how to calculate the length of an individual segment. Well, if we think of this as the change in x on this interval, let's say this is the kth interval, and the change in y, again on the kth interval, then if we know those two quantities, we can calculate the length here by Pythagoras, which we know would be the square root of change in x squared plus change in y squared. So therefore, to approximate the curve length from beginning to end, so let's say from x equals a to x equals b. Okay, so this is x equals a, x equals b. We could sum up all n intervals. So we've broken it into n intervals, we're saying, and we're going to sum up each of these for each segment. And then, to find the actual length of the curve, what we can do is make our change in x approach 0. So each change in x approach 0, or in other words, the number of intervals to increase to infinity. In other words, we'll do a limit. So we'll do the limit as n approaches infinity, or delta x approaches 0, of our sum now I'm going to do one more thing with this. And that is going to be to factor out of the square root sign a change in delta x sub k squared. And that would give me multiplied by change in delta x sub k squared. Just confirm that algebra. And then of course this is just going to be delta x. And what I have here is the limit of a Riemann sum, because I have it of the form sigma function times delta x, which we know is equivalent to the definite integral from the start to the end of this function 1 plus. Now remember, this piece here, change in y over change in x, as n goes to infinity, that will become not an average rate of change, but an instantaneous. In other words, the derivative. So I can write dy dx squared, the square root of all that, times infinitely small delta x becomes dx. And this gives me the length of a curve from x equals a to x equals b, as long as the curve is smooth. In other words, the derivative is continuous. So just to generalize what we've said, if we have a smooth curve that begins at this point and goes to this point, then the arc length, as we call it, length of the curve, is given by this formula. As long as our equation y of x is a smooth one. Okay, and this is doing it in terms of x. But just as with areas and volumes, sometimes it is more convenient to consider our independent variable to be along the y-axis here, where we integrate from c to d. And so the equivalent formula, if you wanted to do it that way, and sometimes you will want to because it'll be more convenient, would be to integrate from c to d the root of 1 plus, now your rise and your run will be reversed when you're using this as the independent axis, so that would be dx dy squared times dy. That's if x of y, x is smooth on the interval c to d. Alright, let's look at an example here. We have part of the arc or curve of y equals x squared between 1 and 4, and I want to find the length of this. So if I'm doing this with respect to x, then my length is simply the integral from the start to the end with respect to x of the root of 1 plus dy dx squared. Well, we know that dy dx is 2x, so that's going to go in here. And so my length will be definite integral from 1 to 4 of 1 plus 2x squared dx. And now depending on your integral and what you get and what you're asked, if you're asked to do an exact value, you're going to have to evaluate this definite integral without a calculator. If you're asked to find an approximation, you could use a calculator. Or if you aren't able or don't know methods for calculating this definite integral, then you'll need to use a calculator. So it kind of depends in terms of how to evaluate it, what you're asked for, and what you're able to do. So we're going to integrate from 1 to 4 of the square root of 1 plus 4x squared with respect to x. And we're going to get an approximation 15.340 is the length of that arc. Now what I'm going to do is take the same question and y equals x squared, but this time I'm just going to rearrange the equation so that x is isolated. So that would be x is plus or minus root y. But since I'm dealing in a section where x and y are both positive, I'm going to leave off the plus and minus. So in other words, we can see that these two things are exactly the same. But what I'm going to do is I'm going to do this integral with respect to y. So thinking of this as the independent axis and setting my integral up with respect to y. So it is a smooth curve, so I can integrate from my low y to my high y in terms of y. The square root of 1 plus dx dy squared. So dx dy is just the derivative of this. Dx dy would be 1 over 2 root y. So that is going to go into this spot. So when I simplify, 1 plus squaring my derivative will give me 1 over 4y times dy. So let's see what the calculator says. And as I type this in, I'm typing it in with using x, but I'm thinking of my x as y. Y is really my independent variable here. 1 plus 1 divided by 4y. Just watch your brackets here so that things turn out properly with respect to y. And as you see, we come out with the same answer. Now I picked a question and chose to do it both ways in terms of x and in terms of y. But depending on the question you're given, one way may be more easily done than the other. Okay, it's not necessarily possible or easy to do it both ways. I just did that to show you how it does work, or how you can integrate with respect to x or y, and how you would do that.